Right, so good news. The first one is up and running. So I've got a board off a second one so this is pretty much the same issues with it. Let's zoom in on this. Where are we? So you've got, yeah, somewhere there. So these emitter resistors burn out because when these transistors go short circuit, there's no rail fuses, so these burn out. So they're open circuit. The output transistors, the big ones, they blow. These ones, the driver transistors on both sides, they blow. But then, let's see if I can get a nice dinky tiny little zoom in. Oh no, I haven't got the button. Right, yeah, so then there is, if I can get to my screwdriver, so there's some there just above the screwdriver, that tiny transistor, that one behind that cap there, those are part of the protection circuit because of the huge voltage applied across the transistors. When these resistors go open circuit, it fries those transistors too, those tiny little SOT23s. These resistors, these 100 ohms, these go from the base of the output transistor to the output rail. They fry both sides. I've already took this one off. What else? There's some, then there's some, once you start getting to the pre-driver, well, the voltage amplifier stage to the driver transistors, there's like some low value resistors, 220 ohms, 1K and stuff, like there's one there, my screwdriver, there's one here, there is a 220 ohm there. So basically, yeah, there's some small resistors will fry as well, and some of these 1N4, 148s go. Basically, a lot of this would be prevented if there was just some low value rail fuses. When these shorted, you'd imagine these would hang on enough for the rail fuses to blow, but it's once these resistors go open circuit, all of a sudden there's nothing clamping the differential voltage between either sides of the drivers and stuff, and then that just backfeeds and fries the lot. What I like of these, I'm going to sketch it out to get the full circuit, but see this, let's zoom back in again. So we've got two potentiometers on this board. This one splits between the emitters of the input transistors, these two tiny ones here. You adjust that, you adjust the DC offset of the amplifier. This one, it goes right up to the bias tracking, the thermal tracking transistor there. Do you think simple enough? That must be a bias adjustment. Well, I don't know if I'm gonna, sometimes light helps, sometimes it doesn't. So if I shine through, so you can see there's some tracks going to it. Well, you notice that outer terminal there, the one that's you can see the most, there's nothing connected to that. This potentiometer, and I've got various versions of these boards, these ones are like 3 years newer or 2 years newer or something. That potentiometer is connected, the two terminals that actually, one goes off to the emitter in the outputs, the bias transistor, and the other goes off up here somewhere. Now normally what you have, the bias transistor, that sort of sits between the base and the emitter circuit, and it alters the resistance there. So it basically alters the amount of bias across that circuit. It sort of basically bias the bias circuit, and then it generates the voltage across it, biases the whole amplifier. So normally you tie two of the pins together because you're just using the potentiometer as a rheostat. You don't need the difference between the inner and outer terminals. You're just using it two terminals basically. So you tie two pins together, go off to the bias transistor, a few resistors and stuff. Well, the two terminals that are tied together on this resistor are the only ones that actually go anywhere. If you take this out, you literally make no effect to the circuit whatsoever. If we look from the underside, where am I? Dim that down a bit. So can you see those two terminals just there tied together? So yeah, just there where my nail's coming in. That's the only two terminals on that potentiometer that connect to anything on the board, as you can see, top or bottom, and they're tied together. So you can adjust this potentiometer everywhere you want and it does nothing. Yeah, and when they've revised the board, they've still not caught that. It's impossible to adjust the bias on this. It's always running in, I've not sketched the circuit out, I'd imagine it's in its lowest setting. Yeah, if that's like giving the, depending on where you put that potentiometer, if it's in the lower part of the circuit, as you reduce the resistance, it will attenuate the amount of signal on that bias transistor and make the voltage across it greater. If you have it in the upper part of the circuit, it will, as you decrease the resistance, it will apply more bias to that output transistor and decrease the voltage across it. So I'd imagine it's configured in the manner, like I said, I've not sketched it out yet, but I'd imagine it's configured in a manner where it decreases bias as you decrease resistance, and it's just stuck in its lowest resistance setting. So yeah, anyway, so it's blown lots of bits. This was the channel, that was all right. This one over here was the blown one. So it's all back on, some 2SA 1943s and stuff, and some driver transistors, a few resistors, capacitors, diodes. If I can get the macro zoom function on this camera to work, if you give me a second, where is it? Let's have a look. It's here somewhere. No, won't let me do it because I've got manual something on. Hang on a second. So if you can look just about in the middle of the wavy screen, you'll see a resistor down there. Yeah, that's one of the new base resistors because my 0805 kit hasn't turned up yet, various mixed resistors. And you can see, look, there's a 2K2 just there. So yeah, you can, with some like 8 watts and stuff, you can actually replace surface mounts if you're very, very careful with standard type resistors. So anyway, let me zoom back out and fire it up. Right then, so first thing you notice with this, it's got 4 bloody fans in it, and they only get faster as it gets warmer, and boy do they kick out some noise, and a lot of noise. But they shift a lot of air. And I do like this arrangement actually, because you've got these ones are exhausting the hot air from the chassis, ensuring fresh air is being drawn in. So I've seen amps like that before, but of course it doesn't mean there's a lot of air going over the heatsink. You can do it the other way round, where you're trying to draw through the vents and blow over the heatsink. But you generally find if you've got a fan up against something, it has a far better job blowing through that than it does drawing air through it into the fan. So up against the grill, blowing through, shifting a lot of air, they're drawing fresh air into the chassis, and these fans here are actually blowing the fresh air over the heat sinks. So yeah, and that really is, there's some fresh air gets drawn in round here as well with the lid on. So yeah, there's a lot of cooling. There's air actually going over the fronts of the boards as well, across all the driver transistors and stuff. So yeah, cooling wise, there's a lot of it, and I think that's purely down to the fact they're trying to compensate for the fact they've got probably not enough output transistors really for the voltage they're putting to them. I appear to have something in my thumb. Yeah, like I said before, I'd probably want to see at least another pair of output transistors for 75 volt rails, but hey, they figured it would be alright, so I guess the only thing left to do is put some music on. Good old YouTube library. Really put it too loud. It's 1:10 in the morning according to the clock over there. I think my neighbours will be happy. So bridge mode just controls both channels just from the one volume control. That one does nothing in bridge. So yeah, up and running. So that's one fixed. So I have, Christ, what do I have? I have another 7 more of these. Yes, I've got 7 more of these to fix in various power. I've got 3 more of the 5000s, 1 of the 4000, 2 of the 3000 and 1 2000 model. So I've got turned up today 1500-volt line or various mixer amps, and I've got coming another pallet load mixture of rack mount 100-volt line mixer amps, class D amps, multi-channel amps, and some PA amps. So I've got like 20, yeah, I've got 35 amplifiers in total that are turning up that need fixing, and some other ones kicking around the house. Like there's one just down, you can't see it, just under that cupboard under there, there's a 100-volt line Adastra mixer channel ampy thingy that needs fixing. So I'm busy. Now of course I've got to get rid of them somewhere. It's alright having the things and fixing them, but they're not making me any money sat on the bench doing nothing. So I don't want to put them on eBay. You get too many chances on eBay. You get too many knobheads buying it, trying to put a broken one back in. That's not the one you sent them out, or no idea what they're doing, breaking it, making out it's faulty, or yeah, people who buy something, don't want it, and then figure out that you won't give them a return on it because you're not a shop, so then actually going and breaking it so they can say it's faulty and want a refund and not another one. And oh yeah, it's all manner of bits and bobs, you know. Yeah, there's some real chances on eBay. Yeah, the old something cheap saying it's broken, knowing that it'll cost you more to ask for them to post it back than what you bloody get for it, even if it's not broken. So you just tell them to keep it and refund them. And yeah, I don't know why. There's some very dishonest people out there. So anyway, that's one working. I need to go to town tomorrow and pick up some bits and bobs to make a dim bulb tester, because I ended up using my lamp with some crocodile clips on it and a halogen bulb in it just to fire it up. And yes, I need to get some bits and bobs to make a dim bulb tester for making testing the Evers easier. Now something else as well. It'll come to me as soon as I press the stop button. It's always the way. Yeah, so anyway. Oh yeah, that's what I was going to. I need to get me some bit. I've got a dummy load somewhere, but it's real old and manky, an old 4 ohm load I made up. So I want an 8 ohm, 16 ohm one, so I'm just going to make one out of like some one. With my old one, it was 40.1 ohm resistors, 10 watts. So it was a 400 watt rated load, and it was good for really load testing amps for prolonged periods. Well, I want to make an 8 ohm one with like an 80 watt dissipation or something. A better one in a case. Yeah, you know, makes testing it a bit better. Some fans and stuff. Yeah, anyway, so yeah, enough waffling on. Yeah, thanks for watching, and catch you next time. I think next one of these I do, could be in the circuit board holder. I might actually film, well I will, I'm going to film doing some work on the PCB itself. I'm going to sketch the schematic out. Like I said, I wanted to get this one going first. You know, it takes time to film stuff and waffle to the camera. Next one I'm actually going to go through what I'm doing as I'm doing it. It's one of those, it's going to be a very long, slow video, but if you're interested in the whole process, you feel free to watch it. So yeah, anyway, thanks for watching, and catch you next time.